Welcome to Quick Learning. We will continue our discussion on the measure and analyze phase of DMAIC project. Through this project, we can reduce the losses in our organization and we can certainly improve the profitability of our plant, organization, and ultimately our company. So we were discussing a example project for the reduction of water usage ratio in a factory. So here in this slide you can see there is a Pareto chart for the source which is showing that how much water is being used for which purpose and for which section. Through this we would be able to analyze what is the main consumption area of water. So those areas that constitute the most of the percentage of water consumption, we have to work specifically on those high consumption areas because the impact of those areas will have overall consumption impact. So here you can see in the red marking that these four areas have the maximum consumption of around 60%, and if we work on these lines then we will be able to reduce overall water usage consumption. Going forward, let's discuss another uh, process analysis. This is for the project of line efficiency for a glass or bottled line. We will just go through the simple processes. The first one is the preparation phase, that we receive the production plan. After production plan, we prepare our mixer and fillers with 3-step and 5-step CIPs. We transport empty bottles from warehouse to line floor. We pick and transport the raw materials that is required for line. After that, the washer is being heated, empty is being loaded. It comes to washer and washer is being loaded and the bottles are being cleaned. That bottles come at filling. Meanwhile, the raw materials are being fed in the relevant areas and the filler gets ready. Once the filler is ready and beverage is prepared, bottles are available, we go for the bricks and CO2 parameters checking. Once these are ready, then it means that we are good to go for our filling process. You can see the first phase of preparation. The second is the startup SOP phase, where we have multiple parameter and the quality checks. If those quality checks are in the compliant range, then we will be able to move forward with the production phase. In production, we will have the filling, date coding, the final inspection of goods, casing of bottles in caser machine, and at the end, the pelletizing of filled bottles. So we, for this, to get the product in final phase, we have the three main processes. Most of the processes run in parallel, and at the end, we get the bottles in pelletized form. So number two is the data collection. We will have to collect the data of the stoppages for this particular line. So we have got data of each section. For example, let's discuss one particular date. On 2nd of January, total production hour is 16 and available time was also 16 hours. In minutes, it's 960 minutes. So the breaks on each of these machines is blower has 108 minutes breakdown, air conveyor 13, filler 60, labeling 60, packaging 41, pelletizer 40, and so on and so forth. So the total running time becomes 638% and the availability comes as 66.45%. Number of bottles filled is this, and the theoretical speed is 250 bottles per minute. So the line efficiency comes at 58%. So we have this sort of data, mainly the stoppages, available time, the machine speeds, the line speeds, and in this way we will be able to calculate the line efficiency of this particular line. After that, we will have the Pareto charts for these stoppages. As we have the data for multiple dates, so we will club this data and we will put it in the Pareto control charts. This control chart is showing that the blower has maximum stoppages of 2623 minutes. Labeling has the stoppages of 2100 and 2036. Then it's air conveyor with 1254 minutes stoppage. Then filler, palletizer, changeover, package changeover, electricity stoppage, packaging material, and the others. Under the stoppages line, you can see here that we have the percentage of each stoppage against the total stoppage of that line. So this shows that 31% of the stoppage is from blower, 25% from labeling, 15% from air conveyor, and filler has 12, etc. So for Pareto analysis, it gives us an idea that if we just focus on first four machines, that is blower, labeling, air conveyor, and filler, then these four machines will accumulate to 84% of the stoppages on that particular line. So if we specifically work on these four machines, we will be very well able to reduce the overall stoppages of this machine, and at the end we will be able to improve the line efficiency of this particular line. So through this complete data, we are able to sort out that blower, labeling, and air conveyor or filler. These are the main problematic areas for this particular line based upon the data that we have received for a particular duration. Another example, and we will just giving it a brief overview. In the next video, we will have complete understanding what is this. So we will make a detailed roadmap of the main key performance indicator that we are going to analyze. For example, for carbon dioxide, we have this detailed roadmap. What is the structure? We have two CO2 tanks, then its valves, then the filters, the condensers, then it is going to the different production tanks and then different production lines, and it's being consumed and different production lines in through different headers. So this is the roadmap of a CO2 or carbon dioxide consumption at any plant. So before analyzing any data or any improvement project, we must have complete roadmap or complete route of the consumption or utilization of that particular material, where it is being used, in how much quantity, when, etc. Then we will be able to diagnose the actual root causes, and then we will be able to fix out those root causes. So I hope today's lecture would have been very beneficial for all of you. For any question, you can just write in comments tab. Until next time, bye bye.